Okay, so I want to make a video that basically just goes over how I made my CO2 laser. Uh, I'll go over some of the coding of it, all the like connections, where I got the parts and everything, how expensive they were, um, a little bit of how it works. But yeah, so I'll start with where I got everything. So it's all really easy to find. Don't worry about that. The everything can be found on eBay. The CO2 laser I got. This is a 60-watt CO2 laser, or laser tube. I got that on eBay for 160 bucks, around that. A 60-watt power supply. I got on eBay again for $137. The Arduino you can get, the Arduino breadboard, everything you can get for like all together around like $10. They're not really not expensive. The pump that I got you could find on eBay once again for like 10 to 20 bucks. You probably don't need a $20 pump. The tubing and everything, once again, you can find those for a few dollars. It's the wood, dumpster dive at a construction site or something like that, or go to Home Depot, go to the 70% off, wood bin. Don't break the bank on this. You don't even need this. If you have a bench top that works well enough, and it doesn't need to be mobile, like mine I made so that you can move it around. If you don't need that, don't worry about it. Just make sure you have a way to attach the laser tube. And once again, nothing fancy. I literally put some of the packaging that came with it in like a little board that strapped it down to the base. Same thing over here. Just something to make sure this doesn't move and is safe, won't break. That's pretty much an overview of what you need and where to get it. So the connections. When it comes to the wiring, these wires come with the power supply. Obviously, they're attached to it. I put the negative terminal on the end that actually fires the laser, and the positive terminal on the other end. I don't know if that's necessary, or the order of them is necessary. You could put the other ones, I think, just to be safe. Like, I just saw it connected like that. Just to be safe, I would just do this. The water, I just put the tubing, attached it to the pump, ran it up to that big nozzle on the end of the tube, then runs down the tube, down to more tubing. I put a copper coil just to try and get rid of some more heat. I don't think this is completely necessary, especially if you have like if this was filled up a bit more and you were running it. I mean, if you were running this for like hours, it might be necessary, but just for a few minutes or even 1 hour, if you have a big enough amount of water, then it'll be fine. If you don't, then you might need something to cool off that water. But so with the Arduino, I wrote a code that anyone who knows how to code, or with Arduino at least, you'll understand this. Basically what this says is that if the button is being read as pressed, then it will fire the laser. And if it is not being pressed, then it runs a function that basically I have put to This delay, that is in milliseconds, so 100 milliseconds, or a tenth of a second. That's how long it will fire the laser. And if you go to the serial monitor and just type in, any value from 1 to 1023, 1023 being full power, it will fire the laser for a tenth of a second. It doesn't have to be a tenth of a second. You could change that variable to however long you'd like. I just put it for that long for the tests that I was going to do. But once again, totally arbitrary. You can use this code, or you don't have to. Once again, the Arduino is not completely necessary. You could just use the 5 volts from the power supply and a button and resistor, and you'll be fine. And a potentiometer. Now, why you need a potentiometer or a PWM with the Arduino, you can control the power. To demonstrate again, I'll put it at like half power. I don't think that showed up clearly, but that basically puts it at half the power. I wouldn't trust that. With my tests, it's not a linear, they're not proportional. I don't know, I just don't trust the PWM to directly correlate to the power output of the laser. I wouldn't trust a potentiometer either, but once again, that might just be me. I don't know as much as some other people might know about this. Definitely do more research than just watching this video or a couple of others. Read blogs and stuff like that. But anyways, so the screw terminals of the power supply, that 5 volts is obviously just 5 volts. The IN is where you could control the power with PWM or a potentiometer. G is ground. You just put the ground of the Arduino or have the circuit connect to ground. That P is like a grounding, so that if there's any like water, like short circuit or anything like that, it'll turn off. That has to be grounded for the laser to fire. The L is to trigger the laser on a low output, and the H is to trigger the laser on a high output. I put it on a high, as you can see. So when it reads 5 volts, it'll fire. With the low, if it reads 0 volts, it'll fire. With the power itself, I just took, like, at least in the US, one of these 3-pronged outlets, just stripped the end of the wire off, and you have the 2 live wires and the ground wire, and just the 2 live wires to AC, and then ground to FG. I just had that connect down to a little power strip that will power the motor, or the pump, and the power supply that you can just plug into the wall. It says that the input should be 110. I have it 120, I think, and it works fine. I don't know. I haven't tested, but to be safe, don't go beyond that range. But yeah, if you want to know about the how I built the actual housing itself, I have this little cage to just protect it during transport, a place underneath to house the cooling water supply, a little place with a wood like separator to hold the computer, Arduino, all the electronics, basically just separating the electronics from the water, making sure that the water is underneath the electronics, so that isn't a risk there. How it works. So the way that I understand it, you might want to do some... If you really want to know more in detail, do a bit more research. The way that I understand it, there's a mix of nitrogen, CO2, and helium in the tube. When you supply a voltage to the tube, the electrons interact with the nitrogen molecules, which interact with the CO2 molecules, which cause them to bend and stretch in certain ways that make them release photons in the range of, I think it was like 9.3 microns, and it might be 9.6 microns to 10.3 micron. Either way, it just release infrared photons. That's all I understand of it. But yeah, I think that's it. If you have any questions, comment. I don't know how fast I can get back to you in the comments, but yeah, I just thought that this would be helpful. I would want a video like this when I first started building this, so hopefully this helps some people out. Alright, thanks for watching. So some things that I forgot to mention. With the how it works, just continuing with that, the CO2 molecules release photons, which bounce between two lasers. This laser is bounces between two mirrors. This mirror is a full mirror. This mirror is a partial mirror. The lengths between those two mirrors amplify the photons with enough energy to come out of the partial mirror with enough energy to burn wood instantly. So as you can see, it's really powerful. Which goes on to the next thing I wanted to mention. This power supply is working at around like 24,000 volts. Granted, it's like 25 milliamps, but still, just be careful. Like, don't be stupid. I would even go further than this. Don't have them just attached with an alligator clip, like, you know, solder them on there, or just attach them in some way to where even if you were to touch it, there would be no connection. Make sure that there's some sort of like stopping block, that you're not aiming the laser in anywhere where it could possibly start a fire or burn someone. Never get your hand there while it's running. Just don't be stupid. Just be safe with it. Last thing, some mistakes that I made. I didn't do enough research when I first did this. The laser tube comes with the gas filled. So you don't have to buy a vacuum machine or get the gases mixed, or where it comes pre-filled with the gas. That's the biggest mistake I made. But other than that, yeah, just do research, be careful. Obviously, this is for a science fair. If you're doing something that is industrial or has any further application that isn't this janky, then this is not the right video for you. I'm going for just, amateurs. But yeah, I hope this video was helpful for some people. And yeah, thanks for watching.